Quick, graph y equals the sine of the quantity 1/2 times x by hand, two different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed. Press pause as needed anytime during the video. The first way is with the sine dance. Recall the graph of y equals the sine of x, one period or wave. Notice the 5 key points of interest. These key points and all points are affected by the parameters in the equation, namely the 1/2 times x inside the parentheses. That coefficient of x, b equals 1/2, inside the parentheses affects the width of the period inversely. The horizontal dilation factor, you may recall, is the reciprocal of that value b. So in this case, the reciprocal of 1/2 is 2. The period of the sine function is normally 2 pi. For our graph, the period is going to be 2 pi times the reciprocal of b, which is 2, or 4 pi. Pause is needed. So the period is 4 pi. We're going to need to use a different scale along the x-axis. So we're suggesting to mark off every pi and mark off from negative 4 pi to positive 4 pi, as we did here. Pause is needed. The initial point is normally at the origin. This point is unaffected by that 1/2 factor times x. So we'll just plot the origin. The end of the period is normally at 2 pi 0, but for our graph it's going to be at 4 pi comma 0 because that's the period. Halfway between the beginning and end of a period is the point of inflection, normally at pi 0. Halfway between here for us is going to be at 2 pi 0. Halfway between the first 2 points of inflection is a maximum. Halfway here it's going to be at pi comma 1. And halfway between the next 2 points of inflection is a minimum, which is going to be at 3 pi comma negative 1. Pause is needed. Connect the points as a sine wave, concave down, concave up. Let's duplicate the wave in the negative direction by going back a full period from each of the key points, in fact all the points. And connect those points, a sine wave, a frown, and then a smile. Comparing that to the parent function, we can see this is one period of the blue parent function right here. Half of the period of sine of 1/2 x is in the same width as y equals the parent function sine of x. There's that 1/2. Pause is needed. Generalization. The period of a sine wave is 2 pi. You can see that here. But what about the period of an equation of the form y equals sine of the quantity some number b times x? Since b affects the period inversely, the normal period is multiplied by the reciprocal of b. That is, the period of y equals the sine of the quantity b times x is 1 over b times 2 pi, which we usually write as the fraction 2 pi divided by b. This is a big deal. We think you should write it down and remember it. To see if we understand that, let's apply this here. So go ahead and state the period for each of the following. Pause to do those and resume when you're ready. So for the first one, 2 pi divided by 3 is the period. Second one, 2 pi divided by that 4 is the period, pi over 2. But here when you divide by a third, you're really multiplying by 3, so the period is 6 pi. Pause is needed. Second way is using a table. So we'll go ahead and use a table with our axes values and ask you to complete the table. Create a second table coefficient of x, which is 1/2 inside the parentheses, affects the width of or the period of the graph inversely. So we're going to multiply each x value by 2, the reciprocal of 1/2. We need to change the units along the horizontal axis because of that too. So we're going to suggest you mark off every pi from -4 pi to +4 pi. Pause to do that. And that's what we did here. So multiplying each x value by 2, 0 times 2 is 0, but the y values are kept the same. Those are not affected by this half. Pi over 2 times 2 is pi, comma 1. Doubling pi, we get 2 pi, comma 0. 3 pi over 2 times 2 is 3 pi, comma 0. I'm sorry, comma -1. And doubling 2 pi, we get 4 pi, comma 0. Pause is needed. Connect the points as a sine wave, concave down and then concave up. This is one period of the wave. Let's plot another one to the left by going back a full period, 4 pi from each point, but especially the key points. And connect as another sine wave, frown and then a smile. And comparing that to the parent function. Now you try one. Graph y equals the sine of the quantity 1/3 times x. Use either method or both for the practice. Also tell us what is the period. Pause to do this. So here's our graph in green. The period is 6 pi. We found it both graphically and also algebraically. Notice that the axes are not drawn to scale.